Let me show you how to plot a donut in 3D, which in mathematics is the shape known as a torus. Above you can find the equation for the torus, and you can see that it depends on two variables, two radii, little r and big R, which determine the overall shape of the donut, the thickness of the donut, and also the dimensions of the inner hole. And this here is a graph of the cross-section of the donut with the XY plane, so we have a sense of what's happening at that level. Now for the 3D plot, I'm going to start with some 3D axes. And in the first step, I'm just going to plot the cross-section with the XY plane. Next, I plot the cross-section with the XZ plane, which is actually two circles, and the cross-section with the YZ plane, which is again two circles. Now, if you go back to the equation of the torus, you'll see that those points with the highest possible value of Z are those with Z equals R. So if you do the cross-section of the torus with Z equals R, what you get is a circle on top of the torus that touches those four circles we had drawn before. It touches those circles at their north pole. And similarly, if you do the cross-section with the plane Z equals minus R, then you get another circle down below that touches the four circles at their south pole. And now that I have a better idea of what the entire shape is, what I'm going to do is fill in circles just like this one, but between that circle and this circle, I'm going to fill in many other circles. Let me show you, like so. And now that we have this full shape, I can start drawing more lines in a different color at the edges. So we draw in a new color the edges of the entire shape, and then also some of the main circles, or at least the segments of the main circles that we would see from our perspective. Add in some more of those smaller circles, at least the segments that we would see from our point of view. And then also add in some of the circles that appear in the horizontal cross sections of the torus. And that's it.